Thank you very much, Dan. Yeah, unfortunately, Frank, which is our IoT operational person, presenting the métier, the business part of IoT solution at Total Energy, couldn't make it today for an urgent constraint, but I'm here. I'm the IT solution manager at Total Energy. My job is to be between the business métier and the IT providers, different providers, and to make sure that the business need is met behind the IoT solution. So I will be presenting here a little bit of experience that we have in Total Energies in terms of IoT, industrial IoT, and also some of the use cases. So a bit solution and the use cases. So storyboard. So the journey began in 2018 with one simple proof of concept, actually, and it was a prototype to detect leaks at the control valves or relief valves at the flaring systems. So it was one business case implemented with one type of sensor. And we managed to build a solution that enabled this kind of detection and early detection of these leaks that for valves that aren't actually monitored by the control system, and enabled preventing massive leaks of hydrocarbons in the environment. And then we said, hey, this is a solution that we need. Then we need to move, scale it and move faster in deploying the solution. And why not grow in the solution and not be particularly with one type of sensor or what type of measurement or one type of solution. So the idea is to grow the solution in a way that it is agnostic to the protocol and the type of measurement. So then the journey of the continuous industrialization of the solution and the scale of the solution began. So either the connectivity and the sensors catalog, etc., and also the IT software part, where we continue to industrialize it in order to have an industrialized and an agnostic solution. So then in 2020, we managed to equip 8 refineries. So more of the work has been done with the midstream, so refined chemicals branch, and we equipped refineries with the LoRaWAN connectivity and integrated to an IoT solution where the solution can be a plug and play for adding more sensors and more data. And then in 2021, we expanded that for other branches like marketing and services branches and exploration production. So even for the upstream, where they can benefit from the use cases and also the sensors catalog, which are plug and play in the IoT solution. And then we tend to have a solution that is fully capable and scalable in order to reach 30K data, because I'm here talking about data, not object sensor. 30K data in end of this year and the next year. So what is IoT in Total Energy? So it is considered as a digital enabler at first, and also enabler for use cases. So mainly the reason why we tend to have this kind of solution is the lack of instrumentation. Sometimes we lack of instrumentation, and it's sometimes difficult to add more sensors in the industrial network, and the control system is not very easy. And with this opportunity of an IoT solution, it's easier to add instrument and have more data for further analytics. So it is a part of a digital program when it is considered as a digital enabler and also generator of use cases. So either there is a use cases generated in the IoT solution, or simply the data is used by other third-party, not particularly third-party, there is third-party, but also internal departments in order to valorize data further and further. So it's fully integrated with an ecosystem of kind of application like data-driven performance applications, digital collaborative environment, and enhanced operator. Okay, so the solution. I tried here to present a bit of, well, a simplified architecture of the solution. We have at this, the left-hand side, the part where we're talking about connectivity in local sites. It can be a refinery, wellhead site, or offshore site. Where we have the sensors communicating to a LoRaWAN gateway. So we typically have 2 or 3 LoRaWAN gateways that are sufficient to cover all the sites, and then connectivity to a central software part, which is all the part on the left, either with 4G, when there is 4G with a secured connection, or with Ethernet if there is no 4G available, for example, for offshore sites. And then we are in only one mutualized IoT software, let's say, which is in Microsoft Azure. And we have the core network, Activity core network we are using, and it's enabling us to go wider with integrating more and more sites all across the world that are part of Total Energies. And there is an IoT platform with features like device managers. So this is more like our interface to manage devices, also add some context to the data and the measurements that are sensed and sent by the sensor. And then a part in data platform in order to follow the organizational data scope, let's say, in terms of storage of data and routing of data into business applications. So finally, we store data in PyHistorian. So this is mainly the typical use of data from IoT sensors. They go to PyHistorian of the site where the sensor belongs, where it is equipped, and also for other applications like PyAF, PyVision dashboards, and Azure Power BI. So we have also use cases in Azure Power BI. So the data is still in Microsoft Azure, and we are valorizing and offering visualization tools to benefit from use cases. Well, a lot of, from an organizational point of view, we have a key. The first one, we have a key team, let's say, that are business team, which are working on the onboarding of sensors. Let's say they validate a new type of sensor coming from a new vendor, and they validate the specification, how the sensor or the object should behave, and send its data to our central platform. And of course, the IT part, in order to make sure that this business request or this need is met and delivered, and also ensure the run of the solution. Local end users and local teams, of course, we try to deploy. So this is one shot. We work with them at the beginning of the deployment of the solution, where there is sometimes a specific architecture that needs to go to the industrial network. Cybersecurity, of course, which is one of the high stakes subjects about the solution. So we are working in accordance with rules, cybersecurity rules from the company, in order to make sure to be compliant in terms of mainly the connectivity part of the whole IoT solution. Architecture, of course, and sponsors, which are part of digital programs for our branches that are funding this deployment and industrialization to make sure to have a scalable and powerful solution. Okay, now I will present some use cases that we managed to have, and they are in production in our sites. So the use cases, so they are based on sensors. So the sensors, as I said in the beginning, the objective is to have a solution that is capable in a plug-and-play way to collect data and send it to Total Energies Azure Cloud and the Data Lake and business applications. So, and the object is the sensor. So we have several types of sensors that are validated and ready to be purchased directly by the site and fully rapidly integrated in the IoT solution and the software. So we have temperature, pressure, valve position, corrosion, vibration, which are already in use in our sites. And for the different topics of use cases or the stakes, so reduction of carbon footprint and use cases for environment, like the first use case that I will be presenting there, and then machine asset monitoring. So in order to detect and prevent abnormal conditions or deviations in the performance of or on the functioning of a machine, like rotating equipment, and also early detection in order to have the ability to have more sensors, and with the software we can have alerts about the deviation before the alert is generated in the DCS system. Okay, so the first use case, which is first we had in the IoT solution, so it is real-time flare leak flare loss detection system. Sorry, and it is an environmental. It is a use case with an environmental objective and HEC, and it is based on a sensor that is equipped on a pipe with two temperature probes. And in order to detect the deviation, if the valve on the flare network releases hydrocarbons, there will be change in the temperature between the pipe temperature and the ambient temperature, and with correlation with other variables that we find in PyHistorian, we can conclude that there is a leak located at this valve. And so this reduces the time to action for operators on sites to tackle the problem. So instead of spending several days without knowing there is a hydrocarbon release, and that is not manageable, and in order to locate it, so this application, we have the data, we have the application in PyVision. PyAF and PyVision dashboard and alerts with email that helps to identify the problem of the flare leaks, and there is an estimation of reduction by 0.15 ton per hour, and I can't mention the saving here, but it's already made it benefits for one of the refining sites in France. So this is actually deployed for 5 sites so far, and the second use case is the machine monitoring with a FFT capability. So we have a sensor, vibration sensor, that is equipped on rotating equipment, that in addition to the temporal data like acceleration and velocity, it calculates fully embedded, calculates the Fourier transform of the signal, and it sends it to the IoT platform, the activity IoT platform, etc. And we process that in order to show a diagnostic interface that helps to detect possible problems with the machine. And this is a return of experience from one site in Belgium, where the application, and so the operator was at home, working from home, and remotely he were able to detect that there is a problem. So at the left scheme of the bottom one, we have the frequencies, we have the magnitude as function of the frequencies, and we can see a peak at the 6K frequency, and that made him conclude that there is a problem with the temperature of the bearing, and there is a problem with the lube operation, which is for this machine was made manually. So after, as you see, after the correction, the temperature of the lube, as we see in the higher graph, was reduced, and we no longer see in the FFT spectrum that there is a problem around the 6K hertz. the problem of the loop of the rotating equipment. So this is actually one of the advantages of the fully integrated IoT solution and mutualized, where you can remotely have higher access, higher, let's say, higher ability to access data and interpret the data with valorization of data, of course, but let's not forget, which is based on the sensor and the IoT solution that made it capable to put that. And typically this kind of diagnostics is based on sophisticated equipment in order to analyze the FFT spectrum, etc. But here with the sensor and the deployment of one sensor that is less than 1,500 euros, an operator from home were able to detect this kind of problem. And finally, final use case I will present today. So this for the solvent cooler temperature monitoring. So this one, the internal slogan we have for this use case is that we say winter is coming. So for this site, we manage, let's say in 2 months, to deploy connectivity architecture and also the sensors, and using the mutualized software part in order to, and we had to do that urgently and quickly, which is a success in terms of timing, where we are able to deploy that, and we had to have a monitoring tool for temperatures of the pipes where there is a solvent cooler before the winter and before the low temperatures, because the previous problem that there is with the extremely low temperatures of the solvent cooler, there is a phenomenon of freezing, and it causes problem and also trip of the production. So with a simple temperature sensor, we were able already to avoid 4 trips in a year, and with the information and alert provided by the system, so based on the IoT solution as well, the operators could act rapidly before the temperature are extremely low, and they took corrective actions in order to prevent that freezing and the trip of the production. So this is the third use case. Well, in my conclusion, I will talk about the challenges. We have cybersecurity challenges that, even with the current context of cyber environment, with the war, etc. So it is becoming more and more complex. So there is a close work with cybersecurity teams and architects in order to validate our architectures, mainly in terms of connectivity part. And also, maybe some of you are already facing this dilemma in an industrial environment where there is also the convergence between IT and IoT world, and our idea is that the IoT is something in between, because for use cases for monitoring, etc., you don't need to connect the system to the control system, so it is independent, and it's not industrial in the industrial network. It's not in the enterprise network. It's between them, and also multidisciplinary team. Well, of course, in Total Energy, we are structured in a certain way. Sometimes the organization is a bit complicated, but so there is a different teams working on that, and mainly because we are still in a continuous industrialization of the solution, but it is subject to be optimized when we reach the permanent regime. And finally, well, there is the ATEX dilemma of sensors. So in terms of procurement, and well, for procurement there is a problem of a shipment and availability of electronic parts, and also in addition to that, there is the ATEX problematic of sensors, which sometimes causes delays in in the availability of the sensor, even if the sensor is ready. So the ATEX certification is very important for us because we are putting sensor in a industrial environment near the assets, in the hydrocarbons, etc. So this is something very, very important for us. So that's the end of my presentation. Please feel free if you have questions. Yes.
If you have a question, could you come up to the microphone to ask? We might only have time for one, so we'll see. And then if you have another other people have questions for Elyees, then you can grab them afterwards, and that's good.
Yes.
Right. Thanks, Elyees, for the talk. I'm sorry to hog the question. I'm sure I can talk quickly, and you can ask the second one as well. You, TWTG, Nadine Herbert, thanks for mentioning all the use cases with our devices, obviously. But you mentioned the distribution between LoRaWAN and Narrowband IoT and LTM. Where do you see that moving over the next 3 to 5 years? Is it going to stick with the distribution that you currently have, 99 and 1, or is it going to,
No.
how's the percentage going to go?
Yes, of course not, because the idea of the solution is being agnostic of in terms of the type of the sensor and the measurement, and also the communication protocol, which sometimes it is more profitable to be using LoRa network when we are talking about big sites, and sometimes it's more profitable to not invest in a LoRa connectivity when it's a completely isolated site with a low stake of number of sensors, where LTM or MD IoT it's more profitable. So this is driven by the priorities we have in terms of use cases and the values that use cases that can generate. And mainly, I think I guess that in the next year and the year after, there will be an increase in the architecture of type MD IoT or LTM. There is a subject on which we are working. We are initiating right now, but of course it won't be 99% LoRa, and it's because it's the whole philosophy of the solution to be completely agnostic to the protocol and the sensor. Okay.
Everyone, please give Elyees a round of applause.
Thank you.